Hello, today's goal, we are going to go ahead and start solving quadratics by using the quadratic formula. You have seen this before in Algebra 1. Today we're specifically going to look at the discriminant, which is the number that we get that's underneath the square root in the quadratic formula. When we go ahead and take a review of what we did from before, we've solved by graphing and by factoring. Please go ahead and try these two out on your own. Remember that when we solve by graphing, our two x-intercepts are our solutions. So in this case, we would get solutions of x equals 2 and x equals 3. When we solve by factoring, remember that you must make sure that your equation is set equal to 0. Here we have no GCF and we do have 3 terms, and so we'll see what multiplies to 6 and adds to -5. Our two numbers are -3 and -2. Remember that we can put those numbers directly into our factors because our a value is 1. When we go through and solve both of those factors, we get x equals 2 and x equals 3, which is fantastic because notice that this is the same equation that we started with at the beginning, and our solutions match with what we had graphically. As I said, today we're going to go ahead and talk about the quadratic formula. It works every single time. Not every single equation is factorable. Hopefully this looks somewhat familiar to you from previous math classes. So our quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Keep in mind that when you do this, you do need to make sure that you have your quadratic in standard form and that it's set equal to 0 so that we can easily get the a value, the b value, and the c value. The discriminant is what we're going to focus on today, and the discriminant is the stuff that is underneath your square root. Only the stuff that's underneath your square root, so that b squared minus 4ac. Notice there is no square root on top of it. It is only the stuff underneath. This is what we call, as we said, the discriminant. And what this does is what it tells us how many real solutions our equation will have. So let's think about what that means. When we take a look at that, we have our opposite of b plus or minus the square root of, let's say it was a negative number that we got underneath for that b squared minus 4ac. Well, let's think about that. What would happen if we had the square root of a negative number? Well, we know that the square root, we have to think about something times itself that would give us that value. And in this case, it's a negative number. We know that can't happen. And so this tells us that we're going to have imaginary solutions, which we'll talk about more later this week. The other thing to keep, we also call those complex solutions. And the other thing to keep in mind is that you can plug that into your calculator and it will indeed give you an error. So in this case, this tells us that there are no real solutions, which means that we have a graph that is not going to hit our x-axis. Oh, that's not the right picture. That is not going to hit our x-axis. So we have no real solutions. Let's say in the next one, our discriminant, or the stuff underneath the root, was 0. Well, negative b, or opposite of b, plus or minus the square root of 0, is just the opposite of b plus 0 and minus 0, which is just the opposite of b over 2a. So in this case, we just get one single number. So in this, we have one real solution. And what that looks like is we have our parabola that just comes down and just hits our x-axis in one place. It never actually crosses, it just comes down and touches. Our last option is when we have just a plain old number under our root. And in that third option, we have the opposite of b plus or minus some number. So we have the opposite of b plus a number over 2a, and we also have the opposite of b minus that number over 2a. So we have two different scenarios that are happening, which is going to give us two different answers, which is two distinct real solutions. And in this case, we have our parabola that goes through and crosses in 1, 2 spots. Remember that we like the quadratic formula because it works every single time. Not every single function is factorable, or not every single quadratic is. And so we want to be able to have something that works no matter what. You shouldn't have to memorize our discriminant. Keep in mind that what we just did was we looked and saw what was actually happening in each quadratic formula. So just think about, how does that square root impact our formula to tell us how many solutions we have? Let's go ahead and flip it over to the back side and start applying this. If you look in the first example, notice that we have our quadratic and it's set equal to 0. That's good because that has it in standard form, so we're ready to go. The first thing that we want to do is we want to identify a is -1, b is -2, and C is -3. Our discriminant is only the stuff underneath the root, so that b squared minus 4ac. Let's go ahead and plug it in. So the opposite of 2 squared, or -2 squared, excuse me, 4ac. So what does that give us? That gives us 4 minus 12, which is -8. Uh-oh, so that's telling us that there's a negative under our square root. So the value of our discriminant is -8. There's a negative under our root. Okay, well, what does that mean if there's a negative under our root? That's telling us that we're getting a complex solution, or we have no real solutions. So at this point, what we know so far is that we wouldn't be able to go any further. In a couple days, you will be, but at this point, we have no real solutions. This graph is not crossing the x-axis. Let's go ahead and take a peek at the second one. The first thing that we need to do is we need to make sure that it's in standard form. X squared minus 8x plus 5, we have to add the 5 to both sides. Now let's go through and find the discriminant. B squared minus 4ac. In this case, we have A is 1, B is -8, and C is 5. When we plug this in, we get 44. That is a positive number. So that means we have a positive underneath our square root. Our discriminant is 44. The positive under our square root means we're going to add and subtract that root 44 to that b. So we have two real solutions. We'll talk more about getting the actual solutions tomorrow. And in this case, you would keep going in order to get the exact solutions. One more example. Once again, put this in standard form. Make sure that you subtract over your 5x and make sure it is in the order ax squared plus bx plus c. Then we go through, we plug it into the discriminant. Find your a, your b, and your c. A here is 2, b is -5, and your c value is -3. When we plug those in, we get 25 plus, right, 25. I added a different number in my mind. 25, and then we have 4 and 2, which is 8, times 3, which is 24. A negative and a negative is a positive, which gives us a positive 49. Once again, we have a positive discriminant, so we have two real solutions. The other thing that's beautiful here is if you notice that he is a perfect square. So the fact that he's a perfect square, when we plug him in, we will have a root 49, which is 7 in there. So something to kind of keep in mind, that you will have nice rational solutions when you have a perfect square as your discriminant. Once again, that's something that we can explore further tomorrow. Reminder from the beginning of the year, anything can be solved as a system of two equations. So remember, we can always use Desmos to help us find those roots. It will give us decimals. It will not give us the exact rational numbers or irrational numbers. So we have to be careful of that. And then just for your viewing pleasure, I did put an additional example at the bottom of x squared minus 6x plus 9. If you want to try that one out, you would notice that you would get 36 minus 36, which would give you that discriminant of 0. So that would be the case in which you have a graph crossing in one place.